So this is me, Raunak Maheshwari from Extreme Infocom. So basically I was kind of not aware of what kind of audience is going to be here. So I kind of designed this presentation to go right from the basics. Uh, so what is internet? In technical terms, we call it network of networks. This is basically, let's assume this is the consumer side. They are accessing. This diagram is from a Wikipedia page of internet, and it was long back. Now this has changed quite significantly by now, but the basics are still there. This is tier 3 network, which is providing broadband to their homes, and then they are connected to either directly to tier 1 sometimes, which are the global undersea cable networks, or tier 2, which are the bigger, larger national networks in the country. They buy internet from these networks and then provide to the home consumers. So yeah, this is basically how internet functions. This is network of networks, and this is how it functions. Tier 1 networks have undersea cables running throughout the globe. Few tier 1 networks is Hurricane Electric, Anurag Bhatia is here. Then there is Tata Communications, NTT, etc., etc. Next slide, please. So now what I am trying to do here is, and this was made yesterday, so it does not have a lot of color. But what I'm trying to show here is the supply side of the internet and the consumer side of the internet. So this is the users. We access internet to kind of have some services like emails, video, for example, YouTube, OTTs. Then there are some CDNs and SaaS services. Now this is what it does. We are on the consumer side, and these are on the supply side. This is how the traffic flows again. I am showing here tier 3 networks, which are the smaller ones, then tier 2, which are the bigger ones, tier 1s, which are global, tier 1s, which are the global undersea cables, and these are the services which nowadays primarily directly connect to tier 1s. Some of them connect to tier 2s, but hardly these services are buying internet from tier 3s. So again, so basically when you request anything, the way internet works in your minds is, the users will request, it will go to maybe the home broadband connected ISP's router, from there to the tier 2s or tier 1's router, and then on to again tier 2's router, and then to the service, the services router, and then this is the way it comes back. This is what we understand from how internet works. But this probably is not true. So before going on to what exactly happens, I would like to differentiate between transit and peering. So let's focus on this diagrams here. So when a network, now there are 3 networks, A, B, and C. When B wants to send something to C, and C wants to respond something back to B, this goes via a network A. The network A is a transit provider. It is basically allowing users of B to interact with users or services of C. So they sell, this is transit. But if B and C somehow figure out a way to connect directly to each other, then A is not required at all for packets which originate at B, destined for C, and similarly packets which originate C and destined for B. So in that case, A is not required. This is what is called peering. So peering is one-to-one arrangement between 2 networks for bilateral exchange of traffic. Clear till here, everybody? So peering is not same as transit. Transit in India is also called internet lease line, ILL. Now coming back, now with this knowledge of peering and transit, coming back to the supply side and consumption side. Now what you see here is the big networks, the supply side, directly connected to tier 2s and tier 3s, who are supplying broadband to your home. So these networks are in effect peering with tier 2 and tier 3s, bypassing tier 1s completely. This does what? This helps reduce cost because the major middlemen are bypassed. It reduces cost. Now they have a different commercial model. For example, YouTube sells ads. So for them, providing this traffic free of cost to tier 2 and tier 3 is beneficial. It helps them control quality. It helps them control their cost, earn more profits. And for tier 2 and tier 3, because they don't have to pay to tier 1s, it reduces their cost. So this is how peering benefits everybody by reduction of cost, and there are some other benefits like reduction of latency, etc., etc. In this slide, I'm trying to show some traffic statistics with respect to peering in transit. In India, percentage traffic available for peering is approximately 75 to 80. So basically, if you're an internet service provider, you can get 75 to 80% of your traffic by peering. You don't need to purchase the entire from the big transit providers. Now, in advanced countries, this figure is 90 to 95. Why I have shown this in red here is because this is low. In advanced countries, this is 90 to 95. Advanced countries like you pick up any country in Europe or Japan or Hong Kong or Singapore or even Brazil for that matter. Why are we lagging behind? Here is primarily because apathy from banks, universities, government service providers. You will not find GSTIN or Aadhaar. They all have AS numbers, or any banks, etc. connected to an exchange. I'm trying to get them to, but I don't know who to talk to. So this is another 10% of your traffic. Actually, Anurag's one of the famous blogs that I really liked was about how for some lot of customers in India, if they wanted to access SBI, the traffic was routed from London. So Indian consumers sitting in India wanting to access SBI, the traffic used to go to London and then come back. Over China Telecom. So this is incorrect. We need to have all government service providers, banks, universities, anybody who has an AS number needs to connect to the exchange. And then due to some heavy regulatory environment in the country, small CDNs like cash CDN, VPN providers, gaming CDNs, I mean, they are not very rich companies, and unfortunately they can't go to all the telcos because they do not have that kind of money. They look for an aggregation point, but because of India's heavy regulatory environment, they are also not coming to India. So this is another 5%. So we have scope of increasing the peering from 75, 80% to 90, 95%. But this needs a lot of regulatory changes. Now this slide tries to show peering in India. Which are the peering cities in India? The major peering cities is Mumbai, Delhi and Chennai. You have 75 to 80% of peering traffic available here. And the next coming up cities are Hyderabad, Bangalore and Kolkata. You have approximately 40 to 50% peering traffic in these cities. So this is, I've tried to map the cities in India. This is how it looks like. Now, the important point is where we lack. We have 1,500 population centers in the country, whether they are tier 3 towns, tier 4 towns, small semi-urban areas, semi-rural areas, which have population of more than 2.5 lakhs per town. But they do not have any CDNs, they do not have any exchanges, there is no peering provider present in these places. It is impossible for all of them to go to these locations. And it is impossible for even for-profit companies to start exchanges in so many locations. So, but then if you want to connect all homes to broadband in the country, which is vision of Viksit Bharat, Digital India, how do you provide content to all these people? So this is what an IX does. So as I said, peering is available in 3 cities in India. But if there is no IX, I mean, even then peering is available. If there is no internet exchange, even then you can peer with various content providers. I'm just showing here how it will happen. ISP1, for example, is connected to all 4. ISP2 is connected to all 4. ISP3 is connected to all 4. ISP4 is connected to all 4. So these are essentially one-to-one relationships between the ISPs and CDNs. So those who are clicking pictures, the presentation will be available to all of you. No need to click these pictures. So this is one-to-one arrangements of peering, which is available and which is not under any license right now. And what an IX does is converts this one-to-one relationships into one-to-many.
Recording in progress.
So basically, ISP1 needs to just create one infra point to reach the exchange, and they will get connected to all the content providers. This allows reuse of infra. Let's face it, when people watched IPL final, when you were watching IPL final, were you watching YouTube at the same time? No, right? So when you are consuming some type of content, you are not consuming other type of content. So an ISP does not need to create a lot of infra to all the content providers. So this is what an exchange does: converts one-to-one peering arrangements into one-to-many. Peering best practices. This is large Indian telco, couple of them. These are their public records. There is a database called Peering DB from you can pick out where they are connected to. And so from India, these are three large Indian telcos: Tata, Airtel and Jio. And this is kind of subset of where they are connected. So from here, you can see they are connected to Frankfurt, Amsterdam, Marseilles, New York, Palo Alto, Los Angeles. For Los Angeles, the fiber probably is going this way. Then they are connected all the way to Brazil, Sao Paulo, Johannesburg, Sydney, Singapore, Hong Kong. All major large telcos in India do this. So basically, essentially, these all countries are countries where interconnection and connecting to the exchange is not licensed, not required to have a license. It's it is liberalized. So the big telcos in the country are benefiting from liberalized telecom regulatory environment in the other countries. At the same time, if you look at TRAI consultation responses, they are not wanting to have the same liberalized telecom framework in India. Best practices for India. Now, this is a complicated slide to explain, especially because the figure is kind of distorted. So this orange symbol here, it shows CDNs. There are multiple CDNs. These are the spokes here are all data centers in the city. Let's take an example of Delhi as a city. Now these are all data centers. For example, somebody's data centers are in GK1, in Bangla Sahib, in Noida, etc., etc. They are all spread across. And these are the orange ones are CDNs. These are the content providers. For example, Google /YouTube, Meta /Facebook, Instagram, Netflix, etc. They are all spread across various different data centers. So the spokes are data centers. This, if you can see this kind of circle, this is an exchange POP. It looked nice in the draw.io. It's not looking nice here. But so these are the exchange POPs. Now, exchange in India requires a distributed architecture. We can't have an exchange in India simply in one DC and where all the content is also aggregated. This doesn't work in India. In India, you need to have a distributed architecture. And this is what I'm representing here. Exchanges, as you see, this symbol is present in all the data centers and sometimes even non-data centers. And these are ISPs. If you can look at this blue kind of color and users, these are internet service providers. So sometimes internet service providers are able to reach the same data center where there are content providers. Sometimes, for example, in this case, there are no content providers. There are no content providers here. Sometimes the ISP is small and not big enough to be able to reach the major content provider, major data centers. So exchange hence needs to be distributed. See, this is the the dotted line represents the exchange fabric. So exchange is present in all the data centers or all important data centers, and sometimes not even data centers. It needs to create its own POPs. For example, Extreme has a POP as far as in RDC Ghaziabad. So I have customers there, about 15 of them. So this is how exchange is ensuring democratizing access to content for smaller and bigger ISPs. So if you're an ISP, let's take this as Ghaziabad. If you're an ISP in Ghaziabad, you're not big enough to be able to reach to GK1 or CIFI Noida. So how do you take content? Either you are dependent on some bigger ISP to sell you content, or if an exchange is nearby you, you connect to the exchange. So what exchange does is it is democratizing access to content for all sizes of ISPs. The prices are publicly declared. Everybody has the same prices. I hope this is clear. So if you are an ISP in a peering city, you need to connect to the nearest exchange point. If you are decent enough, have decent cash flow enough, you should connect to nearest 2 exchange points, at least. Now, what if your ISP is in other peering cities? For example, if you are an ISP in Hyderabad, or you're an ISP in Kolkata or Bangalore. And for example, if you're in Hyderabad, you connect to both Mumbai. So for whatever is locally available in Hyderabad, you connect to the exchange for local peering content in Hyderabad. For the remaining of it, for example, Hyderabad has approximately 50% of peering content available, but then other 30%, 40% needs to come from Mumbai or Chennai. So you need to connect to either Mumbai or Chennai, preferably both the locations to increase diversity and redundancy. Similarly for Bangalore and similarly for Kolkata, we have customers in these cities who are connected to both Extremax in Mumbai and Extremax in Chennai. Similarly, DECX will also have similar customers. Ajay, where are you? Yeah. And in Kolkata, there are, because Kolkata is equidistant latency-wise from all the 3 cities, you have ISPs in Kolkata connected to all the 3 cities. Sorry. And what if you are an ISP in non-peering city? Basically, you connect simply to 2 peering cities, at least to 2 peering cities. For example, an ISP in Patna, they will connect to both Mumbai and Delhi. An ISP in Coimbatore will connect to Mumbai and Chennai. Yeah, that's it. Questions, if any? You guys are reading this slide, right? Yes.
So you mentioned how due to the regulatory compliances, most of the traffic is on ILL instead of the, like for the government and the e-ticketing, all these things, they're not on the internet exchanges, they're on the ILLs. So is there any security issues in an exchange? No, nothing like that.
So, one, they are the government service providers and banks and universities, why they are not connecting to the exchange or peering anywhere is because of unawareness of what benefits an exchange brings. And because they are so vast companies, I an exchange, I'm a small company, I don't have any idea who is the right person to talk in those companies. And even if I find the right person to talk in those companies, there is no KRA or KPI these people have to increase, for example, decrease latency or improve end user experience. So there is no possibility of. So this is the reason they are not connecting mainly. There are no security issues. Exchanges, for example, work on. If you know the network layers, there are 7 layers and TCP/IP there's 4 layers. So exchanges work on layer 2, which is frames. Exchanges have no ability to look into the packet headers.
Got it. Just one more follow-up question. So when you talked about the e-ticketing portals not using exchanges, is it just the ticketing apps like the IRCTC or even the private ones like, Book My Show or the concert tickets? None of
Yeah,
them.
none of them are not using it. IRCTC, CRIS, Book My Show,
Nothing.
Red Bus, etc., etc. Nobody is using.
Okay, thank you.
Hello. What about the Northeast India? How do they connect? Do they
As
connect
I
with the Kolkata regions or?
So Northeast India should connect to Kolkata for whatever local content is available in Kolkata. There are majorly Facebook and Amazon available in Kolkata. So they should connect there to decrease latency for applications depending on Facebook and Amazon. For the rest, they should connect to Mumbai or Delhi.
Yeah, you talked about exchange pops needing to have a distributed architecture. Could you explain the reasons why? Is it because of the variety of traffic that India gets?
So yeah, here let's consider this pop. This is an ISP. This is an ISP in Ghaziabad. Let's assume that this is Ghaziabad and this is an ISP in Ghaziabad. This ISP is small enough not to have fiber across the city to reach various important data centers. So how does this ISP let's suppose there is no exchange here. What are the options this ISP has to peer? They need to buy transport from telcos or depend on some larger ISPs to provide them content. So this is why exchanges need to have a distributed architecture. Otherwise, the smaller ISPs have no chance of connecting to the exchange.
So I want to add on that Raunak. So although the government reps, they know the benefit. I approached NIC multiple times, referring these cases the government side. NIC is the main custodian, or they maintain many sites of the government. But somehow the big telcos, they have the big contracts with them, so they don't want to move to internet exchange. That is the fact.
Sir, I have offered free services. Even then, they don't want to move.
Yeah.
Any more questions or? Yeah.
Is there any possibility to DDoS attack in exchange point? Is there any possibility?
Anurag, you want to take that?
Thanks. Exchanges generally cannot get DDoS because DDoS by definition is distributed. So you can get attacked by your own members, but generally you will not get attacked from over the internet because you would not originate IX prefix in the internet table. But very often people do that. Very often by mistake, you would have either exchange or any of the member originating prefix over the internet. And in that scenario, they can get DDoSed. And I think there was this famous case of Spam House getting blocked, and then Spam House was getting attacked. They were over Cloudflare, and that caused a lot of trouble for AM6 in Amsterdam. And since then, it has been a best practice not to originate IX prefix over the routing table.
Thank you. Okay.
Adding to Anurag, if you see the internet price or internet transit price, so in internet exchange, the if you see it 1G port or 10G ports, so they have very cheaper rates. So if even that DDoS comes via any exchange member, that exchange can kill that traffic. There are some products in the other market of India that protect the DDoS also.
Yeah. If no more questions, I have one more slide to present. So this is my recommendations and request. I had hoped there would be regulators and licensors and also government service providers here. I would just close with one last sentence. This I do at all the forums, so don't mind. Britishers denied us benefits of industrial age. Everybody knows this. Because of the heavy regulations and licenses, we are denying benefits of AI and information age to our kids. We need to change this. Thank you.